Hello everyone, my name is Saeed and welcome to a new tutorial about mandatory occupancy simulation model. In this tutorial we are going to talk about visibility, priority, and some other concepts in task models. In the previous tutorial, if you recall, we had three different types of tasks associated to each of the patients. One of them was simple visit, the other one was taking medicine, and the last one was throwing up. Throwing up is, however, different from the other two, and it's because it cannot be scheduled in advance. So there is no awareness of that when it is happening. Whereas the other two can be scheduled in advance and they do not need to be uh, to have a mechanism for awareness. And in that case, in the context of awareness, we can classify the tasks into two different categories. Expected ones, which can be scheduled in advance, and unexpected ones. But the unexpected ones can come to the attention of the agent or the individual through visual contact. This has been extensively studied in hospitals. So for instance, patient falls are examples of that. Throwing up is another example of that. The researchers and practitioners had been using a space syntax for this type of analysis. OSM offers a very accurate agent-based model and physical-based model and visibility. So it's a very good tool for this type of simulation. Imagine that you will see someone who is hanging over a cliff. If that individual is not a rock climber, then you will actually abandon whatever you are doing right now and will provide help. Or imagine yourself walking in a shopping mall. And in that case, you will be attracted to something which is very visually interesting for you. And then you will change your all of the tasks and you will actually give priority to whatever which comes to your visual attention and you like it. So we have three different levels of priorities in OSM. The lowest ones are the ones that can be done in the main station. So in the nursing station, for instance, a nurse can answer phone calls or she can do some not very important paperwork. The next level are the expected activities, which are known in advance. So for instance, patient visits, delivering medicine, and some other types of care are expected to happen and are known in advance. And the last one with the highest level of priority is actually the unexpected ones. So for instance, a patient falling out from the bed or a patient throwing up. Even though if a nurse is not assigned to that patient, he or she will take care of that and will give priority to that. So with that said, let's go to Revit. Usually nurses are not assigned to 6 patients in intensive care units. So our nurse is actually taking care of patient 1, patient 2, and patient 3. And she will only take care of patients 4, 5, and 6 if it is an emergency case. Let's take a look at the sequences of activities and the changes that I have made in that. So this is the file. I have removed all of the other activities from for patients 4, 5, and 6. And I have also changed through up to emergency visit. I changed the numbers as well. It's because I didn't want you to wait forever for the simulation to show you the important features. So let's go to OSM environment. I have loaded the activities already, and I am going to load the sequences. And let's just start with the main station and then load the sequences from this file. So there is no difference between the emergency sequences, emergency tasks, and the other ones. If we want to make them an emergency, a real emergency task, then we have to go to the edit sequence. First of all, we have to highlight one of these. So for instance, patient 6 is a patient with emergency task model. And in here, we will click on visual awareness field, and then we can assign a visual awareness field to that. I'm going to use the area method and draw the body of the agent, or the area of the body of the patient. And so once you finish this, this task model will be will be only visually triggered. I'm going to pause the video and complete this process for the rest of the emergency visits, and then I will come back to you. So I'm done, and now we can go and okay. So first of all, we can see that the queue is actually much smaller. The number of tasks are more than the number of tasks in the queue. And now we can go and visualize the sequences. I'm going to visualize patient 6, patient 6's sequence of emergency visit. You can see that the visual awareness field has been also highlighted, and the same is true for patient 5, patient 4, patient 3, 2, and 1. So let's run the simulation and visualization. So first of all, we're going to locate the patient, and then in here in the visualization visual setting, I'm going to actually check out a sequence visually triggered, and I am going to run the simulation. So it may take a while for us to see a visually triggered sequence. For that reason, I am going to pause the video and show you the video where these sequences are triggered. So now you have seen that um, once the nurse is actually going to the bedside of patient 2 to pay a visit, then it has visually recognized that patient 5 is in trouble, and that happened in here 14 seconds after its activation. So now if I close this window, you will see that the color of the patient will change, and now it has recognized that patient 6 is also in trouble, and it is going to take care of patient 5 and then patient 6, and then if there is no emergent activity or task left, then the nurse will take care of patient 4. Now patient 2 is again in trouble. So these numbers are not actually very realistic. I put them just for the sake of presentation, so it is not reasonable to see that all of them are all in trouble. In that case, the staffing and the task assignment should change. So the color of patient is red, and it is taking of patient 5 right now. And then whenever all of these emergency tasks are taken into account, then all of the expected tasks will be addressed. So now I guess after visiting the nursing station, the patient will, the nurse will go to the other one. So what is important is actually to notice that this is only happening when the agent is aligned. So the cone of vision is actually visible in here, and it's aligned to see the patients. And if the patient is potentially visible, but the nurse is not oriented in a way that the visibility can be established, this will not be assigned. So because the numbers are not very accurate, we will see a lot of this happening, and for that reason, I'm going to stop this simulation and continue with the rest of the presentation. And let's just stop that and clear the agent and close this window. But just like before, we don't have to visualize the simulation. We can just run the simulation without the animation, and that would be still faster. So I'm going to actually create a simulation for that. And I'm going to run the simulation for 15 hours. Now we have got the results. The results are added to the data control panel. You can see that we have simulated, in each second, we have simulated almost 4 hours. And let's go to the data control panel and take a look at the data that had been added. So simulation 1 has been added. You can see that we have the duration of the simulation, time step, walking distance, percentage of time spent in walking. We have time in main station, and we have activity engagement time. We had them before, but what we have in addition are the new fields of data that are also listed in here. Let me explain what the new numbers are. So for each of the tasks that can be visually triggered, there is a waiting time, and that waiting time is the difference between the task being activated and the task being visually detected. And during the simulation, this process may happen for each of these tasks several times. And if we add all of the waiting times for a task and then finally divide it by the whole duration time, we will come up with a number, a percentage, which is the normalized number. And then we can calculate that for each of the tasks. So for each of the tasks, we have a specific normalized duration, which is a percentage of the duration of the simulation time. And there is a minimum and maximum for that. And if we also average them all, we will get the average normalized duration to detect visually triggered sequences. So in this case, we have seen that the minimum is 1.38% of the duration of the simulation, whereas the maximum is 8.83, and the average is 4.01. So if these numbers are lower, whatever they are, but they are as low as possible, then we have an ideal design layout and we have an ideal scenario which enables the patients in need to be visually detected very conveniently. And if the difference between the minimum and the maximum is tiny, that means that the different patients have equal chances to getting visual attention. And so I guess that this is the interpretation of these numbers. You have to think about what I said. If you have questions, please feel free to share them with me. And the whole idea is that we want to make them as equal as possible, and we want to make the average as low as possible. So this is a transcript of the whole simulation in relation to visually detected scenarios, visually detected sequences. Let's also take a look at the data in 3D, and let's see what's happening in here. Oh, before that, let's actually smoothen the data. Now we have less noise, and we can have better understanding of the results. So as you can see in here, although the nurse has not been assigned to take care of patient 4, 5, and 6, there are still activities in these areas, and that is because of the emergency models that have emergency tasks that have occurred. And you can also see that there is no longer an even treatment for each of the patients. So patient 3 in here has received less attention compared to patient 2 and patient 1, and that is because the layout of the building and the scenario together, both of them. And this is very important because now we have a concrete and solid way for evaluating the effect of visibility and to say that this design has been improved or not. OSM is not a design software, it is an evaluation software, but that evaluation can produce insight for designers to produce better designs. So with that said, I want to conclude this video, and we will be talking about the measurement of each of them individually in the next tutorials. Thank you for being with me so far, and I hope that you have found this tutorial educational and useful. Please leave your comments uh, on the video and tell me if you have any suggestions or if you have any ideas that you want to share with me. See you later.